Okay, number 13 on the midterm review, we are solving a radical equation. This one happens to be a square root. Anytime we solve a radical equation, the first thing we want to do is make sure that radical is alone or isolated in our equation. So our first step here is going to be to subtract that 7 from both sides. After we do that, we have the square root of 3x plus 4 is equal to 4. Now we're ready to take care of that radical. We're going to do that by squaring each side since it is a square root. To clear it, we're going to square both sides. On the left, we end up with 3x plus 4 because the radical and the exponent cancel. On the right, we have 4 squared, which is 16. We'll then subtract 4 from each side and then divide each side by 3. With radical equations, when you have an even radical specifically, and you raise each side of your equation to an even power, you always need to check your answer. So is 3 times 4 plus 4, square root, plus 7, is that equal to 11? Well, 3 times 4 is 12, plus 4 is 16. Square root of 16 is 4, and 4 plus 7 is 11. It does check out, so that's a good answer. Number 14, we have another radical equation, but this one takes a little bit more thought, a little more work because, well, you'll see. We are going to do the same. We're going to start the same way. We're going to subtract x from both sides so that we isolate that radical. We want the radical to be the only thing on one side of our equation. When we subtract the x over, don't lose that 2 that we started with. We have 2 minus x. And then again, clear the radical, so we will square both sides. On the left, that leaves us with just a nice little x plus 18. On the right, this is not 4 minus x squared. You cannot just square each of those terms. We actually need to FOIL this out. So it ends up being 4. That we get a minus 2x and another minus 2x from our inner and outer products. And then our last gives us a plus x squared. The radical's gone, so we're going to continue our solving. This is now a quadratic equation. So we want one side of that quadratic equation to be 0. And we'll then use one of our quadratic solving techniques on it. 4 minus 18 is negative 14. We get a minus 5x and a plus x squared. I'm just going to rearrange that because I like my x squared to be first. But make sure you keep your signs when you reorder your terms. This is a nice little quadratic that looks like it's going to factor pretty well for us. So we could factor or use the quadratic formula or even complete the square if we wanted to. Negative 14, that's going to be a 7 times a 2. To get the negative 5 in the middle, we need a minus 7 and a plus 2. So there's our factored equation. So that means either x, oops, let's back up a minute. Either x minus 7 is 0, or x plus 2 is 0. Here on the left, we add 7 to both sides. Here on the right, we subtract 2 from both sides. So there's our 2 possible solutions. Just like the last one, we need to check these, okay? Especially when you get 2 solutions, you need to make sure you check them. So is the square root of 7 plus 18 plus another 7, is that equal to 2? Well, 7 and 18, that is the square root of 25. Square root of 25 is 5, and 5 plus 7 is definitely not equal to 2. So this is not one of our answers. That's what we call an extraneous solution. We would not want to report that. Let's check negative 2. Is that equal to 2 when we plug it in? So under the radical, we get a square root of 16, which is 4. And 4 minus 2 is 2. Yay, that one does check. So that is the answer that we would report. Next up, the directions give us a little hint. I like that. Solve this quadratic type equation. So this is one of these equations that we can rewrite and then use our quadratic solving techniques on it. What I notice here is that this middle variable, x to the 1/5, if I square that variable, I get x to the 2/5. That's why this is a quadratic type equation. So I want to start off by introducing a new variable. I'm going to say that u is exactly the same as x to the 1/5. x to the 1/5, kind of hard to deal with. U, that's a nice straightforward, easy variable. And if u is x to the 1/5, it would be also true that u squared is x to the 2/5. I'm then going to use this little substitution I've set up to rewrite our equation. Instead of x to the 2/5, I'm going to put in u squared. The plus 5 stays, but instead of that x to the 1/5, I'm going to put in a u, and then we have the plus 6 equals 0. I write it like this because this is now a pretty easy, pretty factorable quadratic equation here. To get a plus 6, 2 times 3 is 6, and if I do a plus and a plus, that gives me that plus 5 in the middle. So either u plus 2 is 0, or u plus 3 is 0. But I don't want my answer in terms of u. Now that I have this nice result, I need to back substitute. I need to go back in my x's. Remember up here at the top, I said u is the same as x to the 1/5. So if u is -2, x to the 1/5 must be -2. Oops. I'm thinking one thing and writing another. There we go. Now, that's not quite solved for x. One little step here, we need to remember that to get rid of that 1/5 exponent, we would raise both sides to the reciprocal power. So the reciprocal of 1/5 is 5. X to the 1/5 to the 5th, those get multiplied together, so they cancel each other out. And -2 to the 5th, don't know that one off the top of my head. It is -32. I probably should have known that. And same thing over here with the -3. -3 to the 5th is -243. Those are our two answers. Okay, next up we have an inequality. This is a little 3-part inequality where we want to keep that x in the middle and move everything else away or outside of that inequality. So the first thing I'm going to do is subtract that 7. I need to do it on the left and on the right. I'm going to come over here where I have more room. So -13 minus 7 is -20. And 11 minus 7 is 4. Then my next step would be to divide by 2. I need to do it on the left and on the right. -20 by 2 is -10. And 4 divided by 2 is 2. This is my answer in inequality notation, but up here it's asking for interval notation. So this is saying x is greater than or equal to 10, and also x is less than 2. So x is bound by those two numbers, -10 up to +2. And my symbols, square bracket, went with the x greater than or equal to 10, and the parentheses goes with x less than 2. So we include the -10, but we exclude the 2. Another inequality. This time, though, we have an absolute value thrown in. So we have to remember absolute values with inequalities. There is a less than case and a greater than case, and they are handled differently. This one is less than. So that's when we take the inequality, or whatever expression is inside the absolute value symbol, and we sandwich that between the +3 and the -3, because when a distance is less than a certain value, that means it needs to be between the two numbers, the positive and the negative. Once we have it set up like this, we are done worrying about the absolute value, and now we're going to solve it just like our last example. I'm going to multiply by 4, so I need to do it on the left and the right. I get -12. In the middle, the 4's cancel, and a +12. Then I want to subtract that 3. I need to do it on the left and on the right. And finally, I need to divide by that 2 on the left and on the right. And I end up with -15 over 2, less than or equal to x, less than or equal to 9 over 2. This does ask for both our answer on the number line and interval notation, so we need to do both of those. Sometimes people struggle a little bit with how to put this fraction onto a number line. If you don't know what that looks like on the number line, I recommended changing it to a decimal. So 15 halves is equivalent to negative 15 divided by 2, which is negative 7.5, okay? So we're not going to use that number. I'm going to keep it as a fraction in our answer, but that helps me visualize where it might be on this number line, and negative 7.5 would be right here, right in between negative 7 and negative 8. And you can do the same thing for the 9 halves. 9 divided by 2 is 4.5. Okay, so again, maybe that's a little easier to locate on the number line. So that's halfway between 4 and 5. And we would shade the area in between. This x has to take a value somewhere between these two endpoints, including the endpoints. So there's our number line answer, and then our interval notation, negative 15 halves to positive 9 halves with square brackets to include both of those endpoints. Next up, number 18, we have a nice little quadratic inequality here. So the quadratic inequality, we have to be careful. We can't solve this the same way we solve a quadratic equation. We use some of the same techniques to get information that we need, but we don't solve it the same way. What we need to do for these polynomial inequalities, or specifically here, this quadratic inequality, is first we have to find our key numbers. Those are the x-intercepts. So we do want to go ahead and factor. So x squared is x times x. 15, 5 times 3 sounds good to me. To get that negative 8 in the middle, they both need to be minus. So what you don't want to do is just take this inequality sign and transfer it to each one of these. It's not x minus 5 greater than or equal to 0 and x minus 3 greater than or equal to 0. These are just our key points. They are our x-intercepts. So x equals 5 and x equals 3. Those are the only two places on this graph that it could possibly be changing signs from positive to negative. So I put those two on a number line, and I use that number line to set up a little sign chart here. This is going to tell me where my graph is actually greater than or equal to 0, which another way to phrase that is, where is your graph positive? So here's my sign chart. I need to pick some x values in the intervals as indicated by our number line. So I need an x value smaller than 3. I like 0. I need something between 3 and 5. How about 4? I need something bigger than 5. Let's go big. Let's go 10. Okay. I take each one of those values and plug them in for x over here on the left. So 0 minus 5. I don't even care what it's equal to. I just care that it's a negative number. 0 minus 3, also a negative number. 4 minus 5 is negative, but 4 minus 3 would be positive. 10 minus 5, positive. 10 minus 3, positive. Now, to get my final result, I multiply the signs in each column. So in this first column, a negative times a negative gives us a positive result. A negative times a positive is a negative result, and a positive times a positive is plus. Again, back to our inequality up here. This says greater than or equal to 0. Things that are greater than or equal to 0 are values that are positive. So we are wanting to include in our answer the part of the number line that has a plus in the bottom row here. So if I go straight up to that number line and look, you can see I shade it right here. That shows me my result. So my answer says for x values between negative infinity and 3, and we're going to include that endpoint because it was greater than or equal to, and also x values from positive 5 to infinity, any x value in this range would give us a quadratic function in this case that is greater than or equal to 0. So there's our result.